Next up, please welcome Magnus Lindström.
Thank you. Okay, so my name is Magnus. I run a startup called Optifuse, and we're making a smart thermostat for electric heating. We would like to think of it like Nest for electric heating, and then Google could buy us as well for $3 billion. But we're not quite there yet. Okay, so just a quick background. I've been working quite a while for E.ON, and the last years doing some smart home stuff. What we did, I'm not going to talk about this really, but E.ON liked to have a building with 8 apartments and a couple of neat features inside. So we ended up having 150 wireless devices in each of these apartments, like measuring important stuff, like how much water is being used every time you flush the toilet, and being able to remotely control everything. So this is where I got some of the inputs for what we're doing now, at least. So I'm going to talk about a smart fuse. And why would you like a smart fuse? Well, what I realized when we made these apartments was that, well, you can control certain things when you use a smart plug. I don't know if everybody knows what a smart plug is. It's quite standard today, you know. Put it into a power outlet and you can connect something and you can remotely turn it on and off and you can see how much energy it uses. And you can do this with really important stuff like a small lamp or your TV. And well, it's kind of cool, but you know, it's not the... We noticed when we did these tests and so on that people realize that, when I measure the energy for these devices, it's actually very little energy. And when we wanted to be, well, smart and calculate how much does this cost you, and they realized that, well, having the lamp on all the time cost me like 10 kronas a month or 5. They actually can have the opposite effect. People don't care anymore of that. So we want to go into the heavy stuff, like what are the things that actually use energy in your apartment or in your house. And one of those are electric heating and other fixed appliances. But you cannot control that in many cases with a smart plug, since, you know, it doesn't have an outlet where it's plugged into. So, and why is this do we have a relevant problem here to solve? Is also an important question before you spend 2 years of your life doing something. And so we, as you should, conducted some interviews. And for example, we meet Dan, who has this holiday cottage out in the woods. And his pain is something which is not going to save the world, but he has a problem, you know. He has this summer house where he goes also in the winter time. When he comes there in the winter, it's really cold inside, since they turn down the heat, not wasting every bit of electricity they have. So they arrive to a cold house and they have their children with them. Children are really whining, and why are we in this cold house? And they end up not going there much at all. So they actually invested like $1 million into a holiday cottage house in the woods, and they end up not going there that often. So then comes the idea of the Optifuse, whatever we should call it. But the idea is that we install something, we provide something that Dan himself can install in just like a couple of minutes. Needs to be really easy. People are very tired of devices that take a long time to install and are complicated. And it should give him remote control, and he should have control of his cottage wherever he is. You know, he worries about are the pipes freezing because the heating is broken, or any other issue. So then comes I have a dream here, but it's a small dream. Like, we want to control the fuses in the house. You know, you have a fuse box in your house, and in your houses it's really hard because you have hardwired automatic fuses. You can't really access them. But in older houses, And this turns out that in Sweden, over half of the houses we have do have the standard old bottle-shaped porcelain fuses still. So it's like here we have a point of access. This is the only way we can access devices like electric heating without bringing an electrician, starting rewiring 230 volts stuff. So we wanted everything in there. We wanted it to be like an automatic fuse. We wanted it to work wireless. It would work forever, and it would just solve everything. And then when you start looking into it, it's kind of problematic actually to build something and put in there. Since, well, as to start with, you can think that we have lots of power. That's like 230 volts coming through it, but you don't have a ground connection and you don't have a phase connection. So you actually just have one potential. So there's no potential difference. So you can't really connect anything. So it's like a power outlet with just one hole in it. So that kind of complicates things. So we need to put a battery in there and start thinking about how to conserve energy and still not using the battery too much. And then with the automatic fuse part of it, I don't know if you've taken apart an automatic fuse at any time, but they're actually quite complicated and like full of mechanical stuff, and not at all very small, and not at all easy to squeeze into a small PCB somewhere. And there's a reason for that, because they're supposed to withstand 6,000 amps running through them. They need to handle that and break it and not melt. That's kind of a challenge for a small electronic component. So we ended up with this type of design instead, that we don't want to be responsible for houses burning down or killing people, so we actually keep the standard fuse in there to be the real protection against everything. And then we work with the contents of the fuse holder inside, making like a big fuse holder that's quite smart. And so we started working with that, and up here you can see a little bit of our first prototyping. Actually, our very first prototype was like, we took a standard fuse holder, you call them, and we took it apart and we drilled a couple of holes through it, and we soldered on a couple of really thin wires that you're absolutely not supposed to have 200 volts running through them. And you can see here we have a very safe installation as well. And like, as this is one of our co-workers, it's we did it for a very brief period. we all thought it'd be okay. And we can actually already here see what we learning from that this isn't quite stable, and was sometimes when we screwed it in, like, things started to fall apart a little bit and we lost the connection. And so now we're using these professional fuse holders, which is made for something different. They're made to make you to allow you to measure the current. So these are normally like connected like these, and then you can have an amp meter clamp over them so you can measure the current through them. So we hacked these, you can say. We cut them apart, and then we connected them to some wireless relays. And let's see if we can. Here's actually a little demo. Okay, so this is the demo at Sarah's house. We are now controlling the lamp here by an Optifuse and a thermostat. So when I raise the temperature or set temperature here, the system should start heating up. And the light turns on to indicate that the heating is now on, since I turned up the requested temperature. And when I do the reverse and turn down the temperature on the thermostat to below what is the actual temperature,
Yeah, the room temperature. The light turns off as intended. Stop.
Yeah, well, so you see, we made a very complicated remote control for a light, but well, it's much more visual to show it with a lamp instead of just having like a radiator which turns on or off. You don't see it, but you have the whole set. You have this hacked fuse. We have a Raspberry Pi which does the communication part of it. We have a thermostat, like a standard IoT thermostat. And we're using C-Wave communication in this setup. That was like the easiest things to work with for doing the testing. And when we got slightly more professional, like these professional fuse holders, and a bit more neater the installation stuff here. So actually, what you see here might look a bit homemade, but we have it running at 2 customer houses, so no fires or personal hazards yet, so it looks kind of nice actually. Well, and we also made an app for it. This is very quick, something we put together to actually be able to remotely control the temperature. So you can just like raise the temperature remotely and see the energy usage of each fuse, and it's kind of nice. We started working with it in February, and we have something that actually runs now. So then looking a bit, I thought I'd talk a little bit about what our aim for the future is, how we would need to have this look a bit neater and nicer. So this is like the very first CAD design. We're ahead of where everything is gonna fit inside, no cables sticking out. And I have one of those actually by accident, of course. Here's like where we 3D printed it. That's the very first idea of the design, and then we had somebody help us with thinking of something that looks a bit more interesting than just like a black or white cylinder. And well, we're actually down to these options now, which also looks kind of like a white cylinder, but but with some more nice features. And it's like big decisions now. Are these gonna protrude or are they gonna be inside here? And we're leaning towards this design. Well, and you can see we had crazy ideas, and then we're like, okay, we're gonna mold this thing. It's gonna be serial production, and it's gonna be very cheap to produce. So we're down to those options right now. We'll see where we're gonna end up with that. And well, so what we're gonna put into this thing then? So as I mentioned, we only have a phase, so we need to run it on battery. But we're gonna break 230 volt with it. We're gonna have communication, keeping it offline all the time, or most of the time. And doing that, we can easily, quickly waste the battery. And you don't want to end up changing battery instead of changing fuses. Like it's not so interesting. So we're gonna put some energy harvesting in here. We're thinking in the lines of current transformer, so at least when there is some power running through it, we harvest energy and we're charging up something. Most likely like we're charging up a capacitor, or maybe like a rechargeable battery. So, but it's tricky, this design part, because you don't know the current that's going to flow through. It's very hard to optimize what's the current transformer you're going to have. And this is like a very crucial part in it. I could also talk about like we're going to have a relay in here, of course, but it's not super simple. We need to be able to break 230 volt at 10, 16, maybe 20 amps. And we don't know what kind of device is on the other end. So here we're actually thinking of we're making our first prototype board now, where we have a combination of a relay and a solid state, like a mechanical relay and a solid state relay, where you can think about that a little bit and see come talk to me later. We'll discuss why we're doing that. But we want to try to cut it at the zero crossing to make things a lot easier for us. But then we don't want to waste too much energy at the same time. So it's a bit tricky. We're working with an NXP processor. It's a Zigbee processor with really low energy usage. And in our final design, we want to go for Zigbee instead of Z-Wave. Z-Wave has actually more support around the world. It seems like it's more putting out devices using that radio technology. But it's a proprietary solution. It makes everything a bit more expensive. And we want to keep it cheap so people can buy lots of these and do lots of cool stuff with it. And I think I'll keep it to that. And then, behold, this is what we have on the way. Our very first own PCB. I can't say too much details about it actually because I just got the pictures. Kind of need to show it to you, and haven't even seen the circuit layout for it for real. And we're expecting to receive them before the end of this month. And then we will still use our professional fuse holders, hooking them up to this, but then that's going to be it. We can actually start working with using these to control electrical heating, electrical boilers, whatever. And our aim is, well, to have like a super neat, user-friendly, remote-controlled thermostat, but also to enable saving lots of energy, 5 to 10% of the electric energy you use in a house, maybe ending up to 1,000 kronas a year for somebody, which means a bit more than just a small light bulb. So, everybody, thank you. Questions? Yeah, I know exactly what you mean. And the question is, we are blocking the UI here, which makes you see whether the fuse has been triggered or not. And that's one of the things in the design that I didn't mention. We're going to have a neat solution called a diode on this. And it's not that it's going to be on all the time, because we can't do that. We don't have the energy budget for it. But the idea is that when the fuse is blown, it blinks with a certain interval. And actually, this is going to be so much easier to make you see which fuse is blown. Because when a fuse is blown and maybe the lights are off, it's not very easy to find which one is broken. But if you have the one battery driven, which flashes to indicate, here's the one that's broken, please replace me. That's yeah, so it's not the perfect UI that you have today. Actually, I'm thinking of maybe just make a fuse holder with the only function that it has a diode and indicates when a fuse is broken. I think we could actually sell more of those. But yeah, please. Yeah. Yeah. Well, absolutely. Yeah, so the question is, it has a 3-phase boiler with 3 fuses, and one of our 2 test customers actually has exactly that set up, a boiler with 3 fuses, and we're trying it out simply, and we're cutting all the 3 fuses at the same time. And of course there could be some second or millisecond of delay in between them, but the device is built for handling that one of the fuses blows, and still it's not going to break if you have a short interval of time with misalignment between the phases. So our idea is just hit it, take all three out, and we turn it off. Yeah. Yeah. Yeah, I hear you. I mean, it's a question of how long will these dear old fuses remain? And I mean, we done a couple of surveys, and it just what we find out is at least that over half of them, half of the houses still have them. And from our queries so far, it seems that people are very reluctant to just change them for any reason, because it's quite expensive to do the replacement. And some people like the old solution, and most people don't consider it at all. They just they buy a house, they move in there, and if everything is working, they do nothing. So it's in general, when you do larger renovations, you tend to change those. And of course, in the future, we can see that, what about the automatic fuses? What should we do about those? But that's for next talk, maybe. Huh? Yeah, nobody else does this. It's patent pending, actually.